I'm going to tell you a little bit about who DN Tanks Nat Gun is, where we're coming from briefly. I'm going to show you some photos of tanks in the state of Indiana. The bulk of my presentation is going, am I on? Can you hear me, Odetta? You good? The bulk of my presentation is going to have to do with the construction procedures associated with an IRWA D110 Type 3 storage tank. So there is a method to the, if you will, a method to the madness on the design as well as the construction. And then I'm going to show you some slides on, some slides on if you do have any concrete tanks. We do have a group that does inspection, such as cast in place inspection or any rehabilitation or retrofitting that we can possibly do for you. But having said that, like Tom was saying, on this particular project, the tank was a major portion of the project, but the site work was just as major. We could operate as a general contractor, which we had considered going into the project, but when we saw the extensive amount of transmission line that was associated with the project, as well as getting up the hill and the site work, we don't do site work, we don't do piping. We count on our site contractor, subcontractor, if you will, or general contractor to take care of that for us. So in this particular case, as with the, if you will, the challenges associated with the project, we decided to work as a subcontractor to a general contractor who would go ahead and take care of all of that preparation, site preparation, if you will, for us. Nat Gun is Nat Gun, who I previously was working for, had been in business for 80 years. Nat Gun 2 years ago merged with a company on the West Coast known as DYK. DYK is out here in San Diego, if you will. Nat Gun is based out of Wakefield, Massachusetts, up around Boston. Having said that, very similar companies. Privately held, family-run organizations do one thing only, and that's design and construct to a D110 type of tank. DYK does a little bit different style of tank, and I'm not going to talk a whole lot about it because you're not going to see it in this area of the world. It's a Type 1 tank where we do a Type 3 tank, which the unique aspects of a Type 3 tank is that we have a steel diaphragm as an integral part of the wall and pre-stress wire which puts the walls into compression. We're going to talk a little bit more about that when we get into the construction phase of this. And we put it into compression so that we're not under a, if you will, cast in place, being under a tension type situation. This is putting everything into compression so that as the hydrostatic forces are experienced inside the tank, that tank is going to move slightly. You won't see it to the naked eye, but it's going to move ever so slightly as it's being filled up and as it's being drawn down. But having said that, my little area of the world is out of Columbus, Ohio, but I cover Indiana, as well as Ohio, West Virginia, and now Michigan. Never been to the UP, and boy, am I looking forward to it. That's only about 15 hours away from my house. But having said that, we've got a number of tanks up in the UP. But we have a national, if you will, presence across the United States. We have 35 crews, and you're going to meet Mark Madrovic, who's our superintendent on this project. We've got 35 Mark Madrovics that do nothing but construct pre-stressed concrete wire-wound storage tanks. One of the attractions for Nat Gun when we merged with DYK was working in the Middle East. That's a learning curve. It's a huge learning curve that we had at one time looked at that, and we realized the core business is the USA, and that's our core business. But there were opportunities there. DYK was already doing that. Mark just came back from Qatar, or anybody who's into soccer, they're going to have the World Soccer deal in 2022 or something like that. They've got a lot of oil, they don't have water. So there are some large water storage tanks associated over there. And Mark happened to be on a project over there working with our sisters, if you're a sister company, DYK, at the time. But having said that, that's where we're coming from. As far as the tanks that we get involved with, volume-wise, the smallest tank that we have done to date in my little area of the world is about 86,000 gallons. The largest one that we have done to date in upstate New York is 33 million gallons. In my little area of the world, I'm usually looking at around 250,000 to maybe about 1.5 million to 2 million gallons. Some larger, some smaller, but but usually in that area. As far as dimensions of the tank, and put a self-sustaining dome, if you will, on the tank, we can go down to about as small as about 26 feet in diameter. Everything is circular. 26 feet in diameter. The largest that we can do and still put a self-sustaining dome is in the neighborhood of about 250 feet. As far as sidewall height that we can do, we can go down to about 10 foot shallow or 85 feet in height. So we can do variables in between there. We build the tank for the application as opposed to the application or our tank driving the application. So whatever it would lend itself, Pat was talking about on this particular project, they did the assessment on how much volume they could use. They knew where the finished floor elevation needed to be. They knew where the overflow needed to be. They know how much volume. That's how big a diameter that we made the tank. So there's a lot of variables that we can get involved with once we get into an application. Some of the aspects that you're going to see, we've got a membrane floor, if you will, a flexible floor wall connection, steel diaphragm that I alluded to previously, an interior reinforced concrete core wall, minimum of 4 inches on the inside of that, and then pre-stressed wire wrapping that around there. We can put a dome on our tank, we can do interior column supports, flat slab roof, or we could be open top. We're used for water, wastewater, storm water, thermal energy storage, which is usually at a university or hospital type application, glycol capture at airports for the de-icing of the wings, which everybody wants done, especially in February and March. But that in a nutshell is what a Type 3 tank is. We are not proprietary. We do have competition. Tom will attest to that during the bidding process, that we are not the only game in town. But it is a specialty, if you will, construction process that we go through, so experience that Pat would have required has it down to whoever Tom is going to be working with, or whoever is going to be building this tank at Southwest BART is a qualified person who knows how to put the puzzle together, if you will. Some of the aspects that you're going to see, that we'll talk about, the steel diaphragm, everything is cast on site. You'll see the beds that are starting to be formed out there on the site today. You can call it tilt-up construction, if you will. We'll be in that phase probably within the next 2 to 3 weeks. Floor construction, typically on water storage tanks, we're flat. Typically we're a flat floor. If we get into a wastewater application, we can be concentrically sloped, we can be reverse concentrically sloped, or we can be eccentrically sloped. So there's a lot of variables that can go into the design of the tank. It isn't just made one particular way. Roof styles that I was just talking about, we can have a cast-in-place type of dome, or we can have precast panels, or we can be flat slab where the tank is completely buried, or we can be open top, just depending on what we're trying to accomplish at that particular time. The question came up as to how much the tank has been buried. We can bury the tank right up to the dome. If we're going to completely bury the tank, we'll do interior column supports, flat slab roof, and completely bury it. But typically we're buried about 4 feet for frost protection on that floor system. In this particular application for Southwest BART, we're differentially backfilled. The area is backfilled higher at the back than it is at the front. So it just depends on what we're trying to accomplish as far as when we're into the design of the tank and how it's going to be utilized. Some of the tanks in the area, imagine this Commonwealth tank coming right up front in Lapel. This was a 200,000 gallon tank. I believe that project is done now, Pat? Worked with Pat and Steve Bender on this project, as we had also at Southwest BART, 200,000 gallon water storage tank. Plainfield, just west of here, a 750,000 gallon water storage tank in a clear well. We thought the tank was beautiful just the way it was, and then they went and built a water treatment plant around it. Well, we're used out in the distribution system as water storage, or we could be a clear well at the treatment plant up in Carmel. We did a 1.5 million gallon water storage tank. That particular tank, here again, we talked about this. I think our tank is beautiful just the way it is, and you don't need to put up all those shrubs to hide it. But having said that, in Carmel at the park, they had some pilasters associated with that tank. Down in Morgan County, we did a 250,000 gallon storage tank. Here again, differentially backfilled into the side of the area there. Roy's project for Indiana American, Roy Francis, in a 1 million gallon water storage tank for Franklin that Indiana American is operating. Up in Goshen, we did an interior column supported flat slab roof on a 500,000 gallon water storage tank. The Mennonite Insurance Company donated the land to the city, and therefore they had some influence as to what that tank was going to look like. And they wanted to put picnic tables on top of that. All this was done before 9/11, and so that their employees could have lunches out on top of the tank, which is fine. Also for Indiana American up around Warsaw, this is a very high visibility application that we had up here where the logo was required on that, up around Route 30 and 15, up around Warsaw. Right around the corner from that, this is the smallest tank that I've been associated with, 86,000 gallons in Pierceton. You can talk about dollars per gallon and get into all that. In Pierceton's application, they have one guy, Chip, who's associated with the project. They don't have anybody that can do maintenance on tanks. One of the reasons they went with what they have here is they aren't going to have to do maintenance. So there were other inexpensive types of tanks that they could have used that might have required some maintenance associated with it, where with this, he's not going to have to be doing that. He's not going to be sandblasting this tank and repainting it. Winnemac on your way up to Chicagoland, 300,000 gallon clear well. When we get into clear wells, we could get into baffling systems or mixing systems, and Pat was talking about that for Southwest BART as far as mixing the water and making sure that for water quality purposes, we can get involved with that. Connorsville with Wessler Engineering, over around Lawrenceburg, 1 million gallon differentially backfilled. I'm so glad that they finally put a fence around this, because all I could think about, if I was a little kid with a skateboard, I'd been flying off that thing, and it's about 40-foot drop off out there, but they've taken care of that. Lawrenceburg, anybody who's been around the Seagram's plant over around Lawrenceburg, this is in the fill area where this is. The soils are absolutely terrible. Those tanks are on piles. Worst case situation you'd ever want to get into, because the deep foundation system that's beneath that is just as much, if not more, than the tanks themselves. So I know if you can ever have that party somewhere else, you look for that, but sometimes you just don't have that option. New Albany, down around the Indiana side of Louisville, if you will. This is another project for Indiana American that we did down in New Albany, 1 million gallon water storage tank. Anybody who knows Scott Ham? This is Scott's project down in Sellersburg. Am I in anybody's way? Can you see okay? Down around Sellersburg. Scott basically built this tank when he was on deployment. I think it was in Afghanistan. With the communication devices, he was getting pictures and everything else back as the tank was being constructed. For any Boy Scouts in the area, the Jamboree every 4 years, the last 2 to 3 years, it's a gathering of all the Boy Scouts all over the United States. The next one takes place on July 15th. We submitted for consideration for 2 tanks, a 6 million and a 2 million gallon tank down around Beckley, West Virginia. This was the rendering that we provided. These are the 2 tanks that we have provided to that site. It's up on the top of a mountaintop. It's 10,000 square acres down around Beckley, West Virginia. If you have any Boy Scouts in your family, and I think you're going to be hearing a little bit more about this because it is a permanent site and it is coming up within the next week, but those are the 2 tanks. This was an aerial before we painted the tanks that we have down there. For what it's worth, I'm going to get into the construction procedures associated with a Type 3 tank. Basically, it's five operations: placement of the floor, the precasting of the steel diaphragm wall panels and dome panels, the placement of those on the tank, the pre-stress wrapping operation, putting the walls into compression, and then the finishing off of the tank. In about 20 seconds, I just took care of a situation where our design engineers have worked all their lives in their careers, but I just wrapped it up. This happens to be up in Fort Wayne. This is a stormwater retention basin, 1.7 million gallon stormwater retention basin, 130-foot diameter by 21-foot sidewater depth, interior column supports, flat slab roof, 12-foot of cover on it. It's a soccer field. But that's what we had. This was a pump station right here. That's 35 feet total and 150 foot open. So that is, gentlemen and ladies, that is a very large hole in the ground, if you will. Bring in a select granular fill, minimum of 6 inches, compacted to a 95% Proctor. Put a 6 mil poly material over the top of that. Take number 4 bars, either on 6, 8, 10 inch centers, depending on the diameter that we're working with. We'll heavily reinforce that. In this particular application, we're going to have a baffle wall. We put that poly material down so we don't have any wicking effect or loss of water to the subbase on that tank. We're going to use a PVC water stop in between the membrane floor and the spreader perimeter footing, and we're going to cast that in the floor up to the center bulb for that floor system. This has to do with the flexible floor wall connection. I told you the walls move. That has to do with making sure that we have a watertight connection at the floor in the wall connection. Not putting any holes in those PVC water stop. Fresh concrete against fresh concrete. We're designing that floor as a flexible floor, if you will, 1/4 inch worth of flexibility per 10 square foot of floor space. Here again, if we had a situation such as in Lawrenceburg, where the soils conditions were absolutely terrible and we had to go to more of a, if you will, a deep foundation system, that membrane floor, which is approximately 4 inches thick, would go to a structural floor because it's going to be a pile cap, if you will, for that particular tank. Oh, going back here, we don't have any cold joints or construction joints in that floor. It's all done, if you will, monolithically, as well as the membrane floor, as well as the spreader perimeter footing. It's all done at the same time, and that'll be coming up within the next week and a half, in that range. Here again, floor process. We're going to, is that mood lighting we're getting into? Or? Okay. Okay. Yeah. We're going to flood that floor for a minimum of 7 days. This is a wet, slow curing process that we're putting on that membrane floor. You can see where that PVC water stop is protruding up above the floor, which will later be taken care of once we put the wall panels up. We're going to take care of the precasting operation on site. Those casting beds are in a location to accommodate whatever size crane that we're going to be utilizing. That all goes into the amount of areas or amount of pick points that the site will lend itself to. In this particular case, we have, because of as tight a site that it is, we have 1 pick point. So we had to make sure that we had a big enough crane or a big enough dog to pick up the bone, if you will, to pick up those wall panels and set those out of the casting beds onto the tank. Continuous steel diaphragm as an integral part. Thank you. 26 gauge steel diaphragm. This isn't where you're going to get the strength in the wall. Strength in the wall is going to be that minimum 4 inches of reinforced precast concrete core wall. Concrete being porous, water is going to get through that. It's going to get through the steel diaphragm. This is where it's going to stop. This is the watertight membrane. As it's sitting in a horizontal plane, if you will, in the casting bed, it has reentrant angles. The angles are wider at the bottom than they are at the top, which creates a mechanical lock, if you will, of the steel diaphragm into that wall. Here's the casting beds. We'll stack those up, say up to 6 high per casting bed. On the dome panels that we're going to do, you can see the re-steel protruding out of that form. That's going to be used because we're going to have various rings, and we'll see that here in a second, various rings of dome panels. And all those dome panels are going to be tied in together in the circumferential joint that we'll see in a second. And you're going to end up with, if you will, a spherical dome. You won't even know that there's panels on top of that as the roof system. Okay, we've got the floor, we've done the precasting operation. Now we're going to, if you will, assemble these on the tank. There's going to be a keyway joint at the base with a roughened area. This is all part of the flexible floor wall connection. And then we've got a 4-point pick, if you will, on this particular wall panel. Picking that panel up, setting that. And we've got jacks at the top of that so that that last ring of dome panels, making sure that we get a smooth transition between those dome panels all the way around that tank. We're setting the wall panels on a 40 durometer bearing pad. We're setting it approximately 7 inches next to there'll be a 7-inch gap next to the last wall panel that was installed. We'll take care of that 7-inch wall slot here in a second. At the top, or depending on what the application is, if I talk to 5 different consultants, I'll have 5 different ways of dealing with how the water is going to get in. In this particular shot, I've got an inlet pipe that's coming up above the high water mark and coming back into the tank, and then I've got a concrete encased overflow on that tank as well. Clear span dome as far as that 250 feet, which is really nice for wastewater applications, especially if you're going to be washing that tank down. But typically, probably 85% of the tanks that we get associated with are dome tanks. This is the two 4 million gallon tanks out at Port Columbus, Ohio for glycol capture. All of this temporary shoring will be taken down out of that tank and taken out after the walls are tied in with the dome. Okay, in this particular slide, it's a little bit larger tank than what we're talking about for Southwest BART, but coming out from the vent, we've got 1, 2, 3, 4. We've got 5 rings of dome panels. The plywood is there just as a forming device to tie all those various rings of dome panels together. This is that plywood and the circumferential joint, that re-steel that was protruding out of those forms is being tied together to the adjacent, if you will, ring of dome panels. And then we're adding additional reinforcement in there. We'll be adding high-strength grout in this circumferential joint, as well as reinforcement between the radial joints between the panels. On the wall slot that's approximately 7 inches wide, we're going to sandblast those joints. We're going to come back, we're going to take a 10 gauge piece of steel. This was 26 gauge. We're going to take a 10 gauge piece of steel, approximately 12 to 14 inches wide. There's threaded inserts. We're on the outside looking in. There's threaded inserts at 1 foot intervals that are welded on that. We're going to take a polysulfide bead acting as a gasket device, if you will, placed on the outside of the tank. On the inside of the tank, we're going to tie off to those threaded inserts that we have welded on there. We're going to put plywood on there. We're creating a vertical joint, if you will. We're going to put high-strength grout into that vertical joint. That plywood eventually will be taken off, but what you're left with is a continuous steel diaphragm or a watertight membrane as an integral part of that wall. Going back to the remainder of that PVC water stop that was protruding out of the floor, we're going to tie that into that wall by what we call a shotcrete cove or a cast-in-place cove. We've got a keyway joint, a roughened area there. We're going to add reinforcement. The water stop that was protruding is going to be tied into that particular area by that shotcrete or cast-in-place cove. We're making sure that we're not getting any bonding effect between the floor and the wall as this ACI certified nozzleman is applying concrete to that flexible floor wall connection. At the top of that wall system where those jacks were located, holding up the, if you will, the last ring of dome panels, we're going to cast in place what we call a dome ring. And on the back side of that dome ring, we're going to apply pre-stress wire under such a force that it's basically going to put that dome ring into compression. When it puts it into compression, it'll basically lift the weight of all of these dome panels off that temporary shoring that we saw earlier, and we'll take that temporary shoring down and out of the tank. You can see the keyway joint, roughened area, reinforcement, dome ring going into place. Tank hasn't been painted yet with acrylic paint. We're going to put a 1/2 inch of shotcrete over the top of that steel diaphragm. All the metal parts of the tank are being put in a high alkaline, high lime environment for corrosion resistance. We're going to take pre-stress wire, 210,000 psi minimum tensile strength. This won't be on the final. 0.192 inch diameter. We're going to pull that through a reducing die as it's applied to the wall, putting that wall into compression. It'll come down to 140,000 psi minimum tensile strength, or 0.168 inch diameter. There will be, in this particular case, close to a mile of pre-stress wire accomplishing that compression application. At no time will the new wire be any closer than 5/16 of an inch to the previous wrap, because we're going to encapsulate all the pre-stress wire in shotcrete, which is a high alkaline, high lime environment for additional corrosion resistance. If you like NASCAR, and I love NASCAR, you'd love to come out and watch the wire winding application. I'm not sure whether it's right to left or left to right. Mark will be able to tell us when we're out on site. Here's the dome ring that's had pre-stress wire, putting that dome ring into compression. There's the application of the pre-stress wire, putting the walls into compression. At every vertical moment, if you will, on that wall, we're going to take vice grips and we're going to put those on a piece of wire and we're going to send a shock through it. It'll come back through a stressometer and demonstrate as to how much force that wire is experiencing at that particular height of the tank. You can call this CYA, you can call it attention to detail. You can say, Dan, which aspect of the construction process is more important than others? They all are. It all comes together. It all has to be approved. Someone is signing off on it. Someone is verifying it as to the construction, each of the construction procedures. We're almost home. The last thing we're going to do, we're going to put tabs at 2-foot intervals around the top as well as at the bottom. We're going to connect those with a filament wound line or a fish line type of material. We're going to put a 1-inch block behind it, and we're going to put 1 inch of shotcrete over the top of the entire exterior portion of that tank wall for additional corrosion resistance. Architectural treatment in the application for Southwest BART, we're not getting into a whole lot of architectural treatment because number one, we're burying most of the tank and we're mounding and putting trees on most of it, so you won't even see this tank. Well, I highly doubt that you're going to see this tank.
We talked about painting it green initially, but nothing was going to satisfy the property owner, so we stayed with a nice tank.
No camouflage.
We could get into a stow treatment, or EFIS, if you will, as far as pilasters or arch system. Butler County, Ohio, north of Cincinnati, they wanted this tank to resemble a horse paddock, which is what they had at the pump station. When I was told that it was a horse paddock, I said, gentlemen, I'm not from the Commonwealth. I'm not sure exactly what is a horse paddock. And they said, well, it's a barn. And I said, well, why don't we call it a barn? And they said, because it's a horse paddock. I said, well, that sounds good. So when I was talking to our design guys, and I shared with them that we needed an architectural treatment that resembled a horse paddock, there was silence. And they said, Dan, what is a horse paddock? And I said, well, basically it's barn. And they said, well, why don't we call it a barn? And I said, well, that's simple enough. I said, it's a horse paddock. So pretty extensive. This is the most extensive architectural treatment that I've been associated with. It's at an upscale golf course and to blend in, if you will, with the pump station. Or we could have a lighthouse like we do up in New Hampshire. Took 4 months to get the water line to the tank, but once they put the light bulb in the tank, it was a lighthouse. 5 million gallon tank out in Texas land. Pilasters did some things with some paint in the pilasters. Chicago land, a very large tank. Didn't do anything to the tank, just did something with the terracing like we're going to do out at Southwest BART. This is a thermal energy storage application in which they wanted an additional, if you will, insulation factor on the outside of the tank and also had their logo associated with that. I know that this is a water application, but I wanted to show you a little bit of flexibility if you ever get involved with wastewater type applications. This is up in Roselle, Illinois. This is a washdown center washdown system that Gabriel Novak is associated with. And we are not going to worry about that today because we're not talking about wastewater. But having said that, as far as if anybody, we've got a group at DN Tanks known as our Concrete Tank Services Group. And what these guys do, they'll go out and they'll do inspection on a concrete tank. Could be wastewater, could be water, cast in place, could be square. What they don't do is bridges or parking lots. But they'll look at your concrete tank. They don't do steel tanks. If you have any type of deteriorated concrete, failed liners, which sometimes cast in place can endure not having a membrane as a part of that. Replacement of the roof. Construction joints, typically cast in place, has a construction joint or cold joint in that floor system. If the tank is operating differently now than it was, let's say, when it was built 50 years ago, and maybe you need some baffling for chlorine contact time, or you need a mixing system inside that tank. These are tank people working on tanks, adding additional lines into that, or if you have an open top tank where you need a wall cap to replace what you presently have. This is the type of thing that these guys can get involved with, architectural treatment on the outside of it. the benefits of using CTS or Concrete Tank Services Group, you're talking about tank people working on tanks. No offense, Tom. But as opposed to a general contractor that works on a lot of different things, has a lot of different expertise, this is the only thing that we do. As far as water storage tanks, as I was talking about before, if you have some disinfection byproduct issues inside that tank and you need a mixing system or chlorine contact time that the tank didn't necessarily have when it was originally constructed, but you need that now, such as plug flow, or what they call plug flow, as far as for the baffling system. We've got, our design engineers have gotten quite well at coming up with solutions along these lines. Typically, we will take direction from Pat or a consulting engineer as to what needs to be done, and then we'll address as to how we could possibly accomplish that inside the tank. There's a number of different ways in your mixing system. There's a red valve or a tide flex type of mixing system that can be utilized, or a solar bee mixing system with solar panels. Those are going to be used at the Boy Scout Jamboree site on that 6 and 2 million gallon tank, solar bee. Or there's a system called PAX. So we're not tied in with anybody, but there's a number of different ways. If you should have to have an application such as that, there's pro and con on both of these. You can either go up the wall or you can go across the floor. There's a number of different ways to skin the cat, if you will. So if anybody's experiencing any types of those problems, there are people who can address those for you. Hydrodynamic, like on the red valve or tide flex, the beauty of that, there's no maintenance associated with it. The downfall of that, it's only mixing when it's either filling up or drawing down. With solar bee, it's mixing all the time. PAX, it's mixing all the time. But you may be using a little bit of electric. There is an impeller involved. So at some point in time, you're probably going to have to do something with that impeller and the solar panels. I imagine they're going to have some issues down the road. We're selling or we're marketing or we're constructing a no maintenance tank. When we put a system in there that is going to need maintenance, it is going to be a reflection on us at some point in time. So we like to stay with something that's not going to be causing a maintenance issue for you down the road. Cleaning of the tank. As Pat talked about, putting in a sump, because you're going to have, something's going to develop in that tank over the course of years. Usually it's silt. It has to do with the, if you will, a byproduct of your raw water and your treatment process. It just happens. If you have those issues now, the tank is not going to be an inhibitor to that. So as Pat talked about, there's ways of cleaning out that silt every once in a while, on occasion. Routine maintenance that you can do by yourself, or you could have your tanks inspected every, I don't know, Pat, do you have a rule of thumb on tank inspection, 10 or 15 years?
I say on elevated steel, every 3 to 5, on concrete, every 5 to 7.
Okay. And there's ways that you can do visuals in between that, so that if a bird's been getting into a screen or something like that, or poking around. Self-inspections that I was just talking about, where you could go out and walk around your own tank just to see if there's any areas there of concern that should be addressed. Retrofitting, here again, after 911, we got into a lot of areas of security around the tanks that weren't necessarily at some of those sites, or adding other operations, if you will, other lines into tanks that can be done. Going back to the D110 Type 3 standard, you're looking at peace of mind, decades of reliability, no routine maintenance that you're going to be doing to this tank. You're not going to be sandblasting, you're not going to be painting this tank, which you should do. If you have a steel tank, it'll last you forever, provided that you do that maintenance. And you don't let it go so far that it's gone beyond the painting. Now you're into repair, but if you stay on top of that maintenance, you're good. With this, you're not going to have to be doing that type of maintenance. Single source responsibility. We're a single source responsibility contractor, specialty contractor, if you will. We're not proprietary. As we talked about, Tom will attest to that. There is competition in the business. We worked with Pat and Steve Bender extensively on this project, as we had in Lapel, on what exactly do you want in the project, what can we do to assist you with as you go through this. We take direction from him, but then we're the people who, I say we're, not myself, my design guys. They're the experts in the industry that will address all those questions for him.
And,
Yes, sir.
since this was an RD project, we had to have competitive bidding, so that was one of the requirements. And Jim, you see that pretty much every time out of rural development. They don't want sole source specifications.
Along those lines, there's a number of projects that have been built in Indiana where the specification was a D110 Type 3. And that was the type of tank, realizing that there were multiple contractors who had experience and had demonstrated the amount of tanks required to satisfy that they did have the experience to do that. They don't necessarily have to have a steel tank as an alternate to that, mainly because Pat did his due diligence as far as the maintenance associated with a steel tank versus a concrete tank, as well as the opportunity to bury the tank, which with a steel tank in this particular application, you weren't going to be able to do. So yeah, rural development has its own unique requirements along those lines. Thank you. Typically, the project starts out with a budget as far as how much is it going to cost for a 300,000 gallon tank budget-wise. We aren't geotechnical engineers, but we review geotechnical reports from the standpoint we're going to have to build our tank on top of whatever that geotechnical engineer says he has there. We'll offer recommendations as far as how we can address any of the challenges, if you will, that may have come out of that report, as far as maybe uplift with a high water table situation, unsuitable soil conditions, rock that we may have. But we'll address that. You can always build a tank there. It's just a matter of, if you get into a lot of challenges, how much money is it going to take to overcome that? And you can bury that tank as deep as you want, but when you start getting into uplift situations, that membrane floor that we had just went to a structural floor for buoyancy purposes. So it just depends on what we're working with there. We'll go out, we'll have a regional estimator take a look at the land, like Tom was talking about, going out as a general contractor, seeing what all he had there. We'll do the same thing from the tank perspective. To get a lay of the land, we'll provide detailed, if you will, tank drawings in a non-proprietary fashion to the consultant that he can put in his particular CAD drawings. And then hopefully we'll have an opportunity to look at the project before it comes out for bid, just so nobody has any heartburn along those lines. That's what a D110 Type 3 tank provider goes through, if you will. Once again, we gave up 80 years of Nat Gun Corporation to now we're 3 years into it, be DN Tanks. So it's hard to get used to that. But long-term employees that we have, like I say, 35 crews that do nothing but build pre-stressed concrete wire wound storage tanks. I've got some brochures up here for anybody who's interested in that. And we've also, hopefully everybody got, now this particular handout is pertaining to Southwest BART and the tank that we're going to see out there. The project, as Pat was talking about, we've only been on site for about a week. So we're getting everything prepped. We're doing the sumps right now. We're going to get the casting beds set up for the tank. If we were there another 3 weeks or 3 or 4 weeks, we'd have a lot more to see. But I think you'll get, after having just seen my presentation, you'll get an idea as to what we're going to be going through in the weeks to come. And there's also a schedule in there of things that are going to be happening periodically. I don't know that you want a whole lot of people running around your construction site out there, but as you drive by that site, you're going to see a progress taking place every so often.